are building a religion. We are building it bigger.
Hi, Lou Covey with New Tech Press. I'm here at the Design Automation Conference. We're doing a bunch of videos. This is one of our recorded ones because our bandwidth is not working too well today, so we can't do the live videos. But I'm meeting today with David McAllister of ASIC Analytic. So, why don't you tell me what ASIC Analytic does, and we'll go on from there.
Okay. ASIC Analytic produces an HDL analysis tool that basically short circuits the debug process. Rather than having engineers spend weeks doing manual debug looking for tedious errors in a design, we look at the whole HDL space, automatic, one pass, no setup, completely telling you everything that's in your HDL, top to bottom, both good and bad.
Okay. Now, how does the open source fit into that?
Our technology base is open source. We use open source software to create our technology.
Okay.
So we have no critical suppliers in our software. We're not tied into any other EDA tools. We're not tied into Synopsys. We're not tied into Microsoft. We're not tied into Cadence. We basically analyze HDL, which is an open language, and everyone speaks HDL.
Okay, so, but it doesn't flow into any of the others?
We take anybody's HDL.
Okay.
Every chip company designs with HDL. Every company spends lots and lots of time on debugging their HDL. We automatically analyze the entire HDL space, linting, circuit topologies, cell libraries, top to bottom, automatically, push button, telling you everything that's in your HDL, giving you a prioritized output so that we can, and basically the engineer will say, at the end of a run, he'll say, either A, thanks for the confirmation, I know that circuit topology was in there, or B, I didn't know that was in there, thanks for telling me.
Okay.
Right? So we short circuit the debug process, that's what we do.
Okay, so how long have you been here? Did you hear Gary Smith's talk on Sunday night?
We did not. We missed Sunday night's talk.
Okay.
I would have loved to have seen that.
Yeah.
But I missed it.
Well, he made a comment about the issue of semiconductor profitability.
Okay.
Because right now it costs anywhere between $30 and $80 million to produce a new semiconductor.
Big bucks.
Yeah, big bucks. And he said, for us to get back to profitability, we have to start designing or providing a way for semiconductor companies to create those same type of complex semiconductors for around $25 million.
I would agree. I mean, the issue, the way I see it as, I use the word productivity, or poor productivity is what we have today, right?
Okay.
It takes forever to get all the polygons in the right place to get done.
Okay.
Right? The fab is ready to go, we just can't get all the polygons there done in a short amount of time with a few dollars.
Okay.
Right? So the space we're in is HDL. Engineers create HDL, and they're running tons and tons of simulations. They have debug loops with silly little errors here and there. The whole design team's on hold for a couple of weeks sometimes for a silly little error they don't even know is there, but they're getting bad simulation results. They're not sure where to look. Eventually they find the problem, but the word is eventually. Time. So if we shorten the debug time, taking off those 2 weeks of every schedule, 3 weeks off every schedule, times how many people on the design team, productivity, profits.
Okay. So your concept is actually reducing the, it normally takes anywhere between 12 and 18 months to produce a new semiconductor.
Right.
So you're talking about bringing it down dramatically.
On the front end side for HDL, we're shaving big time the debug time, right?
Okay.
We're short circuiting the debug time for HDL.
Okay.
Right? We're not on the back end, we're on the front end. So we're aiming towards the front end, short circuiting the debug time.
Okay.
Reducing it substantially. Right?
So who are you working with right now?
We are working with some some IP companies on a development basis. We have their IP in-house. We're using it to develop our tools. We're giving them free analysis. That's where we are today.
Okay, you're giving them the tools and
we're using their HDL. They give us their
Okay.
HDL on
Okay.
an NDA basis. We're analyzing it, giving them our feedback.
Okay.
But we also use their HDL to actually develop our software. It's a mutual benefit right now for development purposes.
Okay, so you would call yourself a company in development right now?
Correct.
Not actually out there selling stuff, so you're not really concerned about making money immediately.
We're probably 1 to 2 months out from beta.
Okay.
And we're saying our software is so easy to use that rather than give away pens or hats or mugs at our booth, we're giving away free pass cards. We have Amazon's Compute Cloud reserved.
Okay.
Our software is installed.
Okay.
We give them a free pass card with a registration code. It's good for a month.
Okay.
We're saying it's that easy to use. There's not even command line options. There's no setup files, no tech files, no configuration, no GUI, no licenses to other tools. Not even command line options. We're that easy to use. So our motto is, if you go in with few assumptions, the fewest assumptions, you have to check everything.
Okay.
If we check everything, we leave nothing to chance. We tell everything about the design to the engineer, and we let them make the judgment. Do I want to look at this, or look at this, or look at this? But it's a prioritized output.
Okay.
Kind of like us to Google, right?
All right.
Because a lot of times if there's a problem, when we make assumptions, we go down a path. We think it's over there. And we don't know, sometimes we make assumptions, it's wrong. We end up taking time to go over there. Eventually we'll get there, but the word is eventually, it's time. We look at the whole HCL space, one pass.
Think of it
all
this
at one,
way.
top to bottom.
Today, companies spend millions and millions of dollars doing physical design, buying the software to do physical design, place and route, whatever. Yet, despite all that investment, state-of-the-art tools, what do? They spend millions and millions of dollars more on DRC and LVS because they don't trust the results of all their investment in state-of-the-art physical design.
Mm-hmm.
So we spend tens of millions of dollars on front-end work, HDL, synthesis, and so on. Do we trust it? Should we? So my argument is we need a comparable DRC or LVS on the front end after synopsis.
Okay.
That's where we are.
So you're talking about your tool actually takes $10 million off the front end.
The leverage we can offer, if we take a 10, 20, 30 person design team, time several weeks of debug, those are big dollars.
David, thank you very much. This has been Lou Covey with New Tech Press around the coffee bar at the Design Automation Conference in Anaheim. Thanks for listening.